Hello friends, in today's question, a transverse wave is described by the equation y naught sine 2 pi, and that is ft minus x by lambda. The maximum particle velocity is equal to 4 times the wave's velocity. So we have to find out the condition which satisfies that the particle velocity is equal to 4 times the wave velocity, and that is the lambda relationship between the lambda and y naught, which will be the maximum amplitude. So this question is quite straightforward. We already know that you can say the particle velocity will be equal to the derivative of this position equation, and the relationship between the particle velocity and wave velocity is given, that is 4 times. So we are going to use that relationship and get this final answer between the lambda and y naught. So we are going to start with the equation that is given to us. So we say given wave equation, so the transverse wave is given as y is equal to y naught, and we have here sine of 2 pi ft minus x upon lambda, where y naught is the amplitude, f is the frequency, and lambda is the wavelength. Y naught is the amplitude, f is the frequency, and lambda is the wavelength. And the wave velocity is represented as v. So wave velocity is represented as v, and v will be equal to frequency multiplied by lambda. So this is a standard equation for the wave velocity, and we can find out the particle velocity by derivating the given equation. So you can say particle velocity, let us call that as Vp, that will be equal to derivative of given equation with respect to time t. So we get Vp is equal to, we have here y naught, and this comes as 2 pi f cos of 2 pi ft minus x upon lambda. And we are given that maximum particle velocity. It means we have to find out the condition when this particle velocity Vp will be equal to maximum, and that is possible when this cosine function is going to have value that is equal to 1. Therefore we can say that maximum value of cos 2 pi, so let's write it again, maximum value of cos 2 pi ft minus x upon lambda is equal to 1. So under this condition, particle velocity will be equal to particle velocity maximum, and we have a given condition which states that the maximum particle velocity is equal to 4 times the wave velocity, that is v. So we already know the particle velocity v, and maximum, you can say this particle velocity when maximum. So this we can also write, because this entire function becomes equal to 1. So maximum particle velocity Vp max will be equal to 2 pi f multiplied by y naught. So we substitute both values, value of the wave velocity as well as the particle velocity maximum. So we get this as 2 pi f y naught is equal to 4 multiplied by v, and v is our f multiplied by lambda. So we have to find out what will be our lambda. So from here we can cancel that. Our f and f goes over there, this goes by 2. So we get lambda is equal to y naught, pi y naught rather, pi y naught divided by 2. So if you check the options that are available to us, we can say option number B is the correct option. So you can say that option B is correct. So this completes the question. Thank you.